Good news for those who love the red planet and dream of living there. For centuries, humanity has gazed upon Mars with wonder. Its reddish hue, visible even to the naked eye, has sparked countless tales of alien life and interplanetary adventures. Today, those dreams are inching closer to reality. Scientists believe that Mars has the potential to support life, not just in some distant future, but perhaps within our lifetimes. This is not science fiction. This is the story of human ingenuity, driven by a relentless curiosity to explore beyond the horizon and a deep-seated desire to find another place to call home among the stars. The journey to Mars will be fraught with challenges, but the rewards are too great to ignore. Let's explore the tantalizing possibility of life on Mars, a future that awaits those who dare to dream big. Mars, though a planet separated from us by millions of miles, shares surprising similarities with our own Earth. This red planet, often seen as a mysterious and distant world, has captivated human imagination for centuries. From ancient astronomers who first observed its reddish hue to modern scientists who send rovers to explore its surface, Mars has always been a source of intrigue and wonder. It has polar ice caps that grow and shrink with the seasons, just like ours. These ice caps are composed primarily of water ice, covered by a thin layer of carbon dioxide ice that forms in the winter. As the seasons change, the carbon dioxide sublimates, revealing the water ice beneath. This cyclical process is remarkably similar to the seasonal changes we experience on Earth, making Mars feel like a familiar stranger. Its days are only slightly longer than Earth's, lasting about 24.6 hours. This similarity in day length means that if you were standing on Mars, the rhythm of day and night would feel almost the same as it does on Earth. Additionally, Mars tilts on its axis at an angle of about 25 degrees, very close to Earth's tilt of 23.5 degrees. This axial tilt gives Mars distinct seasons, with each season lasting about twice as long as those on Earth due to its longer orbit around the Sun. Beneath its dusty, rust-colored surface lies evidence of a once-active planet with ancient riverbeds, vast canyons, and towering volcanoes hinting at a watery past. These geological features suggest that Mars was once home to flowing rivers and lakes, and possibly even a vast ocean. The presence of these features indicates that Mars had a much thicker atmosphere in the past, capable of supporting liquid water on its surface. Scientists have discovered evidence of water ice beneath the Martian surface, a crucial ingredient for life as we know it. This discovery has profound implications for our understanding of Mars's history and its potential to support life. The presence of water ice suggests that Mars may have had the right conditions for life to develop at some point in its history. While liquid water cannot exist on the surface today due to the thin Martian atmosphere, the presence of ice suggests the possibility of underground reservoirs, potentially harboring microbial life, or even acting as sources of water for future human settlements. These underground reservoirs could be accessed by future missions, providing a vital resource for astronauts and helping to sustain human life on Mars. These discoveries have fueled our fascination with Mars, transforming it from a distant red dot in the sky to a tangible destination for human exploration, and perhaps one day, even habitation. The idea of humans living on Mars, building colonies, and exploring its surface is no longer just science fiction. With each new mission, we learn more about this enigmatic planet, bringing us one step closer to making Mars a second home for humanity. The journey to Mars is not just about exploration, it's about the future of human civilization and our quest to understand our place in the universe. The quest to find life on Mars is not just about discovering alien microbes. It's about understanding the limits of life itself and how it might adapt to environments vastly different from our own. Here on Earth, we have organisms called extremophiles, creatures that thrive in conditions we once thought impossible for life to exist. Take, for example, the tardigrade, a microscopic animal that can survive extreme temperatures, radiation, dehydration, and even the vacuum of space. If life can exist in such harsh conditions on Earth, it begs the question, could similar life forms have evolved on Mars, where conditions were once more hospitable? The discovery of even the simplest life form on Mars would be a monumental discovery, rewriting our understanding of biology and the prevalence of life in the universe. Section 4, Engineering and Atmosphere, a controversial necessity. Transforming Mars into a habitable planet will require bold solutions, including the controversial idea of terraforming. Terraforming, the process of modifying a planet's environment to make it more Earth-like, is a concept that has fascinated scientists and science fiction writers alike for decades. The idea is to create conditions on Mars that could support human life, making it possible for future generations to live and thrive on the red planet. One of the most significant challenges is Mars's thin atmosphere, which lacks the density and composition to support life as we know it. Mars's atmosphere is composed mostly of carbon dioxide, with only trace amounts of oxygen and water vapor. This thin atmosphere means that the planet cannot retain heat, leading to extremely cold temperatures that are inhospitable to human life. Additionally, the lack of a substantial atmosphere means that harmful solar radiation reaches the surface unimpeded, posing a significant risk to any potential settlers. To make Mars habitable, we need to create a thicker, warmer atmosphere that can trap heat and allow for liquid water to exist on the surface. Liquid water is essential for life as we know it, and its presence on Mars would be a game changer for any colonization efforts. A thicker atmosphere would not only help to retain heat but also provide protection from solar radiation, creating a more stable and life-supporting environment. This is where the concept of nuclear-powered atmospheric generators comes into play. These generators would be designed to release large amounts of greenhouse gases into the Martian atmosphere, effectively jump-starting the process of warming the planet. The use of nuclear power is particularly controversial due to the potential risks and ethical considerations, but it may be one of the most viable options for achieving the necessary atmospheric changes. By strategically deploying these generators on the Martian surface, we could potentially release trapped greenhouse gases like carbon dioxide from the planet's polar ice caps and regolith, its loose surface material. The release of these gases would contribute to a greenhouse effect, trapping heat and gradually warming the planet. This process would also involve melting the polar ice caps, which could release additional water vapor into the atmosphere, further enhancing the greenhouse effect. This release would trigger a greenhouse effect, thickening the atmosphere and warming the planet. Over time, this could lead to a more Earth-like climate on Mars, with temperatures that are more conducive to human life. The thickened atmosphere would also help to protect the surface from harmful solar radiation, making it a safer environment for future settlers. While this idea might seem like something out of science fiction, it's a concept being seriously considered by scientists and engineers as a potential pathway to terraforming Mars. The challenges are immense, and the ethical and environmental implications are still being debated. However, the potential benefits of creating a second home for humanity are driving ongoing research and discussions. As we continue to explore the possibilities, the dream of transforming Mars into a habitable world remains a tantalizing and controversial goal. Section 5: Nuclear Genesis, triggering a Martian transformation. The use of nuclear technology, while controversial, offers a potentially viable solution to jumpstart the terraforming process on Mars. The concept of using nuclear energy to transform the Martian environment is both ambitious and groundbreaking. It involves harnessing the immense power of nuclear reactions to create conditions that could make Mars more Earth-like. The idea is not to detonate nuclear weapons on the surface, as some might imagine, but rather to utilize controlled nuclear reactions to release heat and energy, similar to nuclear power plants here on Earth. These controlled reactions would be carefully managed to ensure safety and efficiency, providing a steady source of energy that could be used in various ways to alter the Martian environment. This controlled release of energy could be used to vaporize Martian ice, releasing trapped carbon dioxide and water vapor into the atmosphere. By targeting specific ice deposits, scientists could strategically increase the atmospheric pressure and temperature, creating a more hospitable environment for future exploration and potential colonization. This process would need to be carefully managed and monitored to avoid any unintended consequences. Scientists would need to conduct extensive research and simulations to understand the potential impacts and ensure that the process is as safe and effective as possible. Continuous monitoring and adjustments would be crucial to maintaining control over the transformation process. However, the potential benefits are significant. A successful transformation could lead to a more stable and warmer climate on Mars, making it a more viable option for human habitation. The increased atmospheric pressure could also help to retain heat, further contributing to the warming of the planet. A thicker atmosphere would not only warm the planet but also provide greater protection from harmful solar radiation. making the Martian surface safer for future human explorers and settlers. This protective layer would be essential for long-term human presence on Mars, shielding inhabitants from the harsh conditions of space. While the ethical and practical considerations of using nuclear technology on another planet are complex, the potential rewards for terraforming Mars are difficult to ignore. The debate encompasses a range of issues, from the environmental impact on Mars to the long-term sustainability of such a project. Nonetheless, the vision of transforming Mars into a second home for humanity continues to inspire scientists and dreamers alike. The journey to achieve this transformation would require international collaboration, significant investment, and a commitment to exploring new frontiers in science and technology. The dream of a terraformed Mars represents not just a scientific challenge, but a testament to human ingenuity and our enduring quest to explore the unknown.